Hello everyone, this is Zaza from Entertainment reminding you not to forget to subscribe to our YouTube channel in case it's the first time you view our YouTube channel. Okay, here we are still dealing with the cubic functions. Okay, here we do have the problem from grade 12. This one is question 10. Okay, we are given the graph of h at x that is equal to uh, ax cubed plus bx squared, of which is known. Okay, the graph is the turning point. So what is given to us, we know the turning points of which is O and B. And if you can look carefully here, this turning point of which is O is also an x-intercept of this cubic function. Okay, so what is it that we are required to do here? Okay, uh, let us okay, here we are required to show that the value of a and the value of b, the value of a is equal to -1 and the value of b is equal to 6. Look at the mark or location of which is 5 marks. Okay, please guys, make sure that whenever you are writing your paper, a mark is equivalent to a minute. So 5 mark question, that means we have to spend the maximum of 5 minutes on this question. If it happens that you're spending more than that, okay, you might expect that you won't finish the paper or you have to circulate time allocation somewhere else. Okay, I'm not there. Let us go back to the question. Okay, here we're going to show that the value of a is equal to -1 and the value of b is equal to 6. How do we find the value of a and the value of b? Okay, let's just go back to the information given to us. Okay, we know two turning points, of which is this one, of which is O, of which is raised to 0, and the other one, of which is 4 is to 32. All right, what is it that can we do using the information provided to us? Okay, let us start. Okay, here, the first thing that I know that h at x is equal to ax cube plus bx squared. Okay, this is what I know. And there is a point. In fact, I have 2 points of which are turning points. The first one is the O of which is 0 to 0. And the second one is denoted by B. B of which is 4 is to 32. Okay. There is something I know about the turning points of which are stationary points. I know that the gradient at a stationary point is equal to 0. That is what I know. Okay? Meaning the gradient at the point where x is equal to 4, it should be equal to 0. Okay, let me find this gradient at this point where x is equal to 4. How do I find this gradient? I have to differentiate this given function of which is h at x to find a stationary point. Okay, let me go there. Okay, so I'm differentiating this function. Okay, what are the rules of differentiation? You multiply the coefficient of x by a. No, in fact, you multiply the coefficient of x by an exponent and then you reduce an exponent by 1. So the coefficient of x here, it's a. So I have a times 3. Okay, here I have x, and then I go there, 3 of minus 1. Because what the rule says, you multiply the coefficient of x with the exponent and make sure that you reduce that exponent by 1. Okay, moving forward here. This one is a coefficient of x, so I should multiply it with by 2. Multiply by 2x, and I should reduce it by 1. Okay, meaning here it will be 3a x squared plus 2bx. Okay, this one is h prime x. And I know the value of x at the turning point. I know the value of x at the turning point, and that value of x is 4. Okay, meaning I have 3 a y c x, I replace it with 4 square it plus 2b multiplied by 4. All right. Okay, I know that the gradient at the turning point is equal to 0. H prime of 4 is 0. Then here I'll be left with 3a, 3a, 4 squared. It is 16 plus 2 times 4 becomes 8b. Here, if you can multiply 3 times 3 times 3 times 16, it will be 48. So I'll be having 48a plus 8b, which is equal to 0, meaning I can divide throughout by 8, and I'll left b plus, if I divide 48 by 8, I get 6, which is equal to 0. Oh, 6a. Add 6a. So b is equal to minus 6a. Okay? That is equation number 1. Let me call this one equation number 1. What else can I do with this? Because if you can look carefully here, I only used x value of the turning point. I did not use the entire point. What if I decide to use the entire point to the original function given to me? Meaning I can use the entire point on the original function given to me, so that I can find also the value of a and b. So I'll end up having 2 equations, and I'll have to solve for unknowns simultaneously. I know that there is a point. The point is b, and that point is denoted by 4 is 32. Yeah. So, meaning, since I do have the function of h at x that is given to be ax cubed plus bx squared, meaning when I see h at x, because h at x is the same as y, but it's just that this one is in a function notation. So here, meaning where I see h at x equivalent to y, and y is equal to 32. So here I have 32 being equal to a, where I see the x, I plug 4. It's 4 to the power of 3 plus b, and then here to be 4 is 4 squared. Okay, let me erase this 3. Let me erase this 3 and write it. Yeah, now it is more visible. Okay, I know that. Okay, now I have 32 on this side being equal to a. 4 cubed is equivalent to 64 plus b, and 4 squared is equivalent to 16, meaning I can make this, I can divide throughout by 16. Dividing throughout by 16, if you say 32 divided by 16, you get 2. If you say 64 divided by 16, you get what? 64 to be 4. 4 times a to be 4a. Okay? Plus 16 divided by 16 is 16 plus b. Meaning if I want to make B also a subject to the formula, I will say B is equal to 2 minus 4A. It's the matter of taking this 4A from this side to the other side. So the sign will change. Since here it was positive, when you shift it to this side, it will be negative. All right. This one is equation number 2. And I know from equation number 1 that my B is equal to minus 6A. And on the equation number 2, B is equal to 2 minus 4A. Meaning since this one is equal to B and this one is equal to B, that implies that this one is also equal to this one. Okay. So as the result, I can say minus 6A is equal to 2 minus 4A. So here I'm saying equation number 1 I equate it with equation number 2. Yeah. So okay, taking this one to the other side becomes minus 6A plus 4A, which is equal to 2. Here you end up with minus 2A being equal to 2. If you divide both sides by minus 2, you will end up with what? With the value of A being equated to minus 1. Wow. Let us go back to the question that was given to us. Wow, we were required to show that the value of A is equal to minus 1. So that means we are still on the right track. The value of A is equal to minus 1. Now I want to find the value of B. I know that B is equal to minus 6A. The fact that I know the value of A now, that is equal to minus 1, that means when I see A, I can replace it with minus 1. So that makes B to be equal to minus 6 times minus 1, of which makes B to be equal to 6. Finally, we did manage to prove that the value of A, or we did manage to show that the value of A is equal to minus 1 and the value of B is equal to 6, of which is exactly that was given to us, that we're supposed to show that the value of A is equal to minus 1 and the value of B is equal to 6. 5 marks is ours. Okay, moving forward. Here we're required to calculate the coordinate of A. Let us go to the graph, to the diagram given to us. Where is the value of A located? Okay. Now you can see that, okay, A is an x-intercept. So is x-intercept. Meaning, for you to find A is the x-intercept where the value of y is equal to 0. Okay. The fact that I know the value of A, I know the value of what? Of B, that makes it much more easy for me to write the function now with a known variables, of which is h at x being equal to, instead of ax cubed, now to be minus 1 times x, which would be minus x cubed. Plus, instead of writing bx squared, I will have to write what? 6x squared, since now I know the value of what? Of b. Okay, so here I'm required to calculate the coordinates of A, and A is the x-intercept. Okay, it's x-intercept. What is it that I know about x-intercept is that for every x-intercept, the value of y, you should let y to be equal to 0. All right. Meaning here, my y is equal to h at x. It's just a notation. This one is the equation form, and this one is in a function, is a function notation. This one is an equation notation. So here I'll end up having minus x cubed plus 6x squared being equated to what? To 0. All right. What else can I do here? What if let me take minus x squared as a common factor. So here I'll be left with x minus 6 being equal to 0. Why do I now have x minus 6? When you multiply the 2, you'll get minus x cubed. But when you multiply the 2, you'll get plus 6x squared. That makes minus x squared to be equal to 0, or x, or else what you can do to avoid destruction or confusion, you can just divide throughout by minus x squared. So here you can divide both sides by minus x squared. It's minus x squared both sides. So you are now left with x minus 6, which is equal to 0. So the value of x is equal to 6. Let us go back also to the diagram given to us. Yeah, you can see that, okay, there are two values of x here. Because if you can look carefully here, instead of writing it like this, it was going to be, you can also write this one as, let me erase this. Since the function that you are working with is a cubic function, so it should have more than one root. Okay, so here it's minus x squared that is equal to 0, or x minus 6 equal to 0. So here you can divide both sides by minus 1, so you'll end up having x squared being equal to 0, or x is equal to 6. On this side, that makes x to be equal to 0. In fact, it's 2x intercept, but they're just sharing one root. So you have x being equal to 0, or x being equal to 6. So since I want the one for the coordinates of a, so I'm not using this one, I'll use this one, x, that is equal to 6. So if you can take 6 and plug it here, also look at 0. So as the result, the coordinates of a is equal to, the coordinates of a is given by 6 is to 0. All right, moving forward. Okay, here we are required to write down the values of x for which age is increasing. All right, let us go back to the function of ours. This function is a decreasing function. It starts from negative infinity up to positive infinity, but the function is decreasing. So we are required to find what? We are required to write down the values of x for which h is increasing. If you can look carefully here, the graph is decreasing from here, and when it reaches 0, it starts increasing until it reaches to the peak where x is equal to 4, and then from there it starts dropping up to infinity. Okay, so meaning these are the values of x where my graph is increasing. Okay, so the graph is increasing. The fact, in fact, this one I should not write. My graph is increasing from every value of x that is greater than 0, and every value of x that is less than 4. So if you can look carefully here, what is the difference between what I'm doing now and what I did previously? Here I'm just circling the values of x where the graph start changing from decreasing to increasing, but this one is not included. That's why I'm circling it with an unshaded circle. Unlike when I'm shading it, that means those points are included. So here, write down the values of x for which h is increasing. So from 0 up to 4, where x is from 0 up to 4, but 0 is not part of the set, and 4 is not also part of the set. So you can write this, or you can write it in this interval notation, or you can write it like this. So it's where x belongs to this. So this is the set of elements where the graph is increasing, provided that x belongs to a real line or real numbers. Okay, moving forward, look carefully here. The first question was asking for the values of x such that the function is increasing, but here we want to find where the graph change its concavity to being concave down. Okay, so here the graph is smiling, that means it's concave up, and the graph here is set, which makes it be concave down. So how do you find the values of x for which the graph is concave down? Okay, this is what you should do. You know h at x is equal to minus x cubed plus 6x squared. Okay, so you have to differentiate this one to find the stationary point, of which is minus 3x squared plus 12x. And you have to differentiate this one again to find what the point of inflection. Okay, the point of inflection, so minus 3 times 2 becomes minus 6x, and this one, the exponent of this one is 1. 1 times 12 becomes 12, and when you subtract 1 here, you'll end up having x to the power of 0, and we know that x to the power of 0 is equal to 1. In fact, every real number for x belongs to real numbers. So for every real number to the power of 0 is equal to 1. So here it will be plus 12. And I know that h double prime x at the point of inflection is equal to 0. So this one is minus 6x plus 12. So taking this one to the other side, you end up with 6x being equal to 12. Divide both sides by 6. So the value of x here is equal to what? Is equal to 2. So if you can plug every value of x greater than 2, you will get what? You will get a negative result. So those negative results imply that the graph is then concave down. So meaning for every values of x greater than 2, provided that x belongs to a real line, the graph will be concave down. You don't include 2 because 2 is the point where the graph start to change its concavity, but you don't know whether is it going to change it to be concave up or concave down. So you check the values greater than this one and the values less than this one. Those are the values that tells you that, okay, my graph from values that are greater than that one, it is concave up or concave down. For the values who are less than this one, is that concave up or concave down. So please do not write it like this. No, 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 no. This point is not is not part of the set. You just say for x greater than 2. I hope this video was productive or was helpful to those who are struggling with cubic functions or finding the concavity increasing, function being increasing or decreasing. Yeah. So if you ever need some clarity, please make sure that you write in the comment section. Please don't forget to subscribe to our YouTube channel. Please, if the video was fruitful, make sure that you like our videos. You can even comment. We will reply to your comments. Thank you. Looking forward to meet you in my next videos.